In this video, we are going to discuss vector model of atom 4, that is the fourth part of this vector model of atom. And in this, we are going to discuss introduction of electron spin and concept of total angular momentum J. And finally, we will draw a vector model, actual vector model of atom, including L, S and J. Since you know that Bohr, first of all, Bohr proposed the theory that electrons revolve around the nucleus in circular orbit, and Sommerfeld explained that, corrected it, that they revolve in the elliptical orbits. The Bohr theory in combination with Sommerfeld, that is Bohr-Sommerfeld correction theory, was in good agreement with the observed spectra of the hydrogen atom. Means the hydrogen spectrum has been fully explained by Bohr theory. But as far as other spectra like alkali atom, spectra of alkali atoms, where doublets were present in the spectra, could not be explained by Bohr-Sommerfeld theory. That is, there are two main drawbacks of Bohr-Sommerfeld theory. That is, the first one is it could not explain the spectra of alkali atoms where doublet structure are found, as well as second, it could not explain the anomalous Zeeman effect where the spectral lines have been further distributed to give 4, 6, 8 lines extra in their spectra. So these two drawbacks led to the concept of new phenomenon, and Ullmann and Goldsmith in 1925 they proposed another theory that not only the electron, when electron is revolving around the nucleus in circular orbit, it not only revolves in the nucleus around the nucleus in circular orbits, but also it spins about its own axis. And he came with a new concept of electron spin, and it in similar fashion he explained quantum mechanically that the value of S, that is the spin magnetic moment, that is the orbital angular momentum, spin magnetic moment, spin angular momentum, can be written as S is equal to, capital S is equal to under root of S into S plus 1 into H upon 2 pi. This is S, right? The spin angular momentum. In similar fashion as L was there. L was under root of L into L plus 1 into H upon 2 pi. S is S under root of S into S plus 1 into H upon 2 pi. That is, the electron not only revolves around the nucleus like this, but it also spins, means like this. So due to this spin motion, it has got spin angular momentum and spin magnetic moment, mu s. Also there, mu s is called as ms, you can say, spin magnetic moment of the electron. So the z component of this is given as sz, and sz is equal to ms into h upon 2 pi, right? Here the s value, he showed that the s value, this s came out to be 1 upon 2, right? S is equal to 1 upon 2, right? And ms can take values as ms, it can take value from minus s to plus s, that is plus half and minus half. So that is minus 1 upon 2. Sz can take value from plus minus s, right? So it can take values, ms can have values plus minus s, that is plus half and minus half, right? Plus half and minus half. This is the value of ms. So now we are with that is spin angular momentum. Spin angular momentum S given as under root of S into S plus 1 into H upon 2 pi, and ms, that is plus minus S, where Sz, the component of this along the field direction, that is Z, is given as ms is to H upon 2 pi. These two give rise to, that is, if I say mu s upon S, right, the gyromagnetic ratio, mu s upon S, that is the magnetic moment for spinning electron to the spin angular momentum, this ratio as obtained in the orbital case, there is a difference, gyromagnetic ratio for this. There in the orbital motion, the gyromagnetic ratio gamma L was equal to E upon 2m. Gamma L is equal to E upon 2m, right? But in case of spin motion, spin for spin motion electron spin, or for electron spin motion, this value is double the value of gamma L. That is, mu s upon s is 2 times mu L upon L, or it is equal to E upon M, right? So mu s upon s, the gyromagnetic ratio for electron spin for the same electron is double the orbital gyromagnetic ratio, that is E upon 2m, right? This is the concept of electron spin, that is, we have introduced electron spin also in continuation with the orbital motion. Now we have to couple these two to give rise to another magnetic moment, that is total angular momentum. So they came with the Goldsmith and Ullmann, they came with the concept that the total angular momentum J is equal to, he came with this concept that J is equal to L plus S. That is L plus S. If this is L, then this L and S, that is J is equal to L plus S. This can have values, two values. If L and S are in same direction, that is S is in clockwise direction, S can have two orientations, clockwise orientation or anti-clockwise orientation. So if S is clockwise, then J, the value of J comes out to be L plus S. Then L is greater than S, right? Sorry, J is greater than L. J is greater than L. And J is equal to L minus S. J is less than L. These two values. Because here S is in opposite direction, right? Anti-clockwise orientation. Here it is clockwise direction orientation. Here I have shown you J is equal to L plus S this, J is equal to L minus S is this. This is the total angular momentum. And if you want to see how these two are coupled, so coupling, after coupling, J takes the value as J is equal to L plus S, as J is equal to L plus S, L plus S. So J can take the value J is equal to J into J plus 1 under root H upon 2 pi, right? J can take value J into J plus N into H upon 2 pi. And Z component of this, JZ, this is from quantum mechanics. Quantum mechanically, it has been proved that J comes out to be under root of J into J plus 1 into H upon 2 pi, and JZ is equal to Mj into H upon 2 pi, right? JZ is equal to Mj into H upon 2 pi. These two, JZ is this, J is under root of J into J plus 1, where J, as I have shown you, J was equal to L plus S and equal to L minus S. These two values, J can take values from L plus S to L minus S. And moreover, J is always positive, J cannot be negative. So we take the mod values of these. That is, J is equal to mod of L plus S and J is equal to mod of L minus S. Here we have shown, I have shown you. This is L plus S, that is J is equal to L plus S and J is equal to L minus S. Right? Total angular momentum is this. So if I say draw the vector model of atom, then in vector model of atom, this is the vector model of atom. L along this direction, right? The L is along this direction, S is along this direction, S is along this direction. So as you can see, this is the direction of J. Means the L, that is the tip of this orbital angular momentum, precesses about J. This is L, this one is L, this one is L. So L precesses about J in this radius circular orbit, and S precesses about this in this circular orbit, that is L sine theta and L sine theta dash or S sine theta dash theta. If you say this makes an angle of theta, then L sine theta, and if theta dash, then S sine theta dash. This is called as vector model of atom. Now